Hi everyone, and welcome to the Units Study Guide video. In this video we're going to be going over units, unit price, and then the idea of rates. And that makes up pretty much all of this section of Unit 1. So let's get into it. In the first part we're going to be talking about units. And so units are just a way to describe what we're measuring. So we're going to be measuring things, and you're going to have to include units on those measurements so that we all know what you're talking about. If I say I'm 5 tall, you're going to look at me and go, 5 what? That's units. The units help you understand what the numbers mean. And that's really, really important, this idea that the units help understanding, because we are going to use units as a tool to help us understand problems. Maybe up to this point they've kind of been an afterthought for you whenever you've used units, but in this section we are going to use them to help us solve problems. So you'll see that in a little bit. But let's get into some examples of actual units. We've seen lots of units already. We'll see them going forward, where we've talked about dollars. Dollars is a unit. I have 5 money. Well, what kind of money? What do you mean? $5. That's a lot different than having 5 pennies or having 5 quarters. Right? These mean different things, even though they all are just the number 5. So dollars is one. Another common thing we're going to measure in this class, especially in the next unit, is distance. Okay, so we're going to measure distance, or you could think like length, stuff like that, in inches, feet, meters. You could do centimeters, millimeters. Again, all of these are telling you something different about your measurement, but it's all distance. You can think of it. Okay, and then another big one, which actually relates to speed, which we'll get to, relates to rates, which we'll get to, is speed. So feet per second, miles per hour. How fast are you going? How slow are you going? Okay, so these are the common ones, although we're going to, you could see lots of different units that talk about lots of different types of measurements in your life. But the common ones, things like money, distance or lengths, and speed. Okay, so those are the ones we're going to use right now. So here's our green question mark. That means we should try these before, we just try them on our own and then finish the video. So pause here, and what you're going to do is you're going to try each of these. And all I'm asking you to do is pick the right units for what I'm talking about here. And you got to use the context of the sentence, okay? So pause the video, try them. All right, you've tried them. Let's see how you did. So the first one says, I am rich. I have 100. So 100 what? What does it make sense to have if you're talking about being rich? Now, of course, rich can mean a lot of different things, but here, hopefully you're thinking, it means money. So you're probably not doing too well if you have only 100 pine cones. Or 100 meters, that's distance. How do you even have 100 meters? $100, that makes sense. So here, we're thinking dollars. So $100 makes sense because we're talking about money, it seems like. How about the second one? I can hold my breath for 25. So here there's actually 2 answers that fit what we might be talking about. So hopefully you read that sentence and you go, oh, I must be talking about time. Then that immediately hopefully makes you think inches. I don't know about that. Get rid of that. So let's think about this. What's more reasonable? This is something you're going to have to do, right? You're going to have to be able to ask yourself, like, oh, okay, 2 units here maybe makes sense, but one of these is realistic and one's not. So I got to think about that. Think about how long you can hold your breath. 25 seconds is a lot more reasonable than 25 years. You're not going to be able to hold your breath for 25 years. So we're going to pick seconds here. Okay? So sometimes it's not only just what the sentence is telling you, it's you got to think about what answer is, really makes any sense at all, even if another one technically fits time as your measurement. Milk tastes great. I drink at least 15. Okay, so all 3 of these could work as an amount of liquid. Ounces, gallons, hot tubs. But again, we got to think about this. 2 of these don't make any sense for what a person could actually do, and you have to think through that. Ounces is correct because 15 gallons a day would be quite a lot of milk, probably too much for us to drink. And a hot tub full, or 15 hot tubs full, is definitely too much for us to drink. So you can't just go, okay, here in this question I'm asking about an amount of liquid. So then as soon as I see a unit that works for that, I pick it. No, we've got to think about the actual unit, how big it is, in this case ounces, or how long, seconds. And we've got to say, does seconds work or does years work? Even though they're both time, which is what I want, only one of these makes sense. Right? So, this can get a little bit more complex as you go through. So, at this point, that's units. You just got to be able to remember that they exist and we need them, and pick out the right ones. If you're going through a problem and you don't have them attached to the number. So, something pretty interesting. You can click this link here and check this out. There's actually a very long history of units, or not maybe necessarily specific written down units, but ways that societies have and cultures have measured things and tried to stay the same when they measure something. And so really kind of cool stuff. You can see through history what types of units have been used by what groups of people. Really, really cool stuff. So click this, go check it out if you're interested in that. Okay, awesome. So that's not too bad. Now let's move on to unit price. So unit price is the next, again, it's just units. So we're not going away from units, but it's kind of a specific type of unit. So the unit price is of this form, which I wrote here. The unit price of some item you want to buy. I have ketchups down below, so you can think that in your head if you want. How do we find that? It's the total price of the item divided by the total units of the item. Okay? So what does this mean? Well, we can just use this example down here if we want. This is a good one to use. I have 3 bottles of ketchup here that I found at Stop and Shop. Okay? Well, the unit price is telling you kind of how much ketchup are you really getting for the price. That's the way you can think about unit prices. What's the real deal here? And the reason we use something like unit price is because we often will have bottles of differing sizes. So if I just asked you right here, this one, what's the best price? You might immediately go, well, obviously, this is the best price. It's $1.99. But you've got to do a little more work here. Is it really the best price? Because true, it is cheaper. And, I get that when we say best price, we're thinking cheaper's better, right? Which it is what we want. But think about this. For the $1.99, you're only getting about 20 ounces. For $3.49, you're getting 38 ounces. So it's true you pay more for this, right? Which seems like it makes it the worst deal, but you're getting more. So how do we compare these two things? That's the question. How do I actually compare two things that have different amounts? Right? How do I do that? Well, I've got to use unit price. So unit price helps us compare two things that have different amounts of that thing. So ketchup, 2 ketchups, different amount of ketchup in each. I want to know what's the best deal overall, best bang for my buck, as the saying goes. How do we figure this out? It's the same thing every time. It's not too bad. All we do is we take the price, right here, $1.99. We'll do this one real quick below, even though it's below here. $1.99. That's my price, and you can write a $sign or write dollars. And we divide by the amount we have, 19.5 ounces. Okay? So we set this up, all right? And again, you can use a $sign or the word dollars if you want. If it's confusing to you to have the units on the left here, then that's totally fine. That's no biggie. We can just get rid of that. So we can do this instead if it feels more comfortable that way. I think it might be a little easier that way. So then how do we figure out what this actually is? Well, we got to plug it into our calculator. So I'm going to type 199 divided by 19.5, and that ends up giving me 0.102. So I'm rounding to this third decimal place, the 1.102. And then I put the units, dollars per ounce, or if you prefer, you can kind of do it differently by going dollars per ounce. Totally fine either way. All right, so what is this telling me? It's about 10 cents for each ounce of ketchup. And so why is this useful? Well, guess what I can do now? I can do the same thing for this bigger bottle, and that'll tell me which is the better deal. All right, so let's try it. Let's do this one right here. So we'll put the work right here. So for bottle number 2, again, it's what's the price? $3.49 divided by, and this one is 38 ounces. Okay, and so let's do the math. What do? We type in into our calculator. We go 3.49, and then we hit the divide symbol, 38. And what do we get here? We end up getting 0.092. So again, I'll round to 3 decimal places. And what is that? That's dollars per ounce. Again, though, you can use the dollars word if you want here. So maybe when you first looked at this, you said, oh, the Nature's Promise. It costs less. It's better. Well, if you want to answer the question, not what costs less, but what costs less per ounce. So, what's the better deal for what you're getting? Actually, this second one, the $3.49, is really the better deal. Okay? So, what's a quick way to see that? Maybe you're kind of thinking about it like, oh, really? Like, how does this help me? Like, why do I care about this? Well, let's pretend you're shopping for your family, and you, just from experience, know that your family in 1 week will go through one of these bottles, the second bottle here. So about 40 ounces. Okay? So I've got to get that much ketchup. My family loves ketchup. We're going to kill that bottle. No ifs, ands, or buts. So what do you choose to do? You could get one of these bottles, or to get about the same amount here, you'd have to get 2 of these bottles. So just a quick calculation tells me 2 times 199, right? What's this going to be? This is going to be just shy of $4, so about $3.98. Look at this. Compare these. This actually was about 50 cents more expensive for you to buy. Now, you might look at that and go, well, I got a little bit more ketchup. That's true, but not very much more, right? You only got 1 ounce more for 50 more cents. That's not good. That's not a good deal. It's not worth it. So it just depends on your situation, right? You might decide, I really don't use very much ketchup. I'd rather spend $1.99 now than $3.49. In the long run, after many times you buy ketchup, if you keep doing that, you're actually going to lose out on money eventually. That's what this is telling you. Is that if you're in it for the long haul, you should buy this ketchup because it's a better deal. It's more ketchup for the price you're paying. Right? But that's what makes these things difficult, is there's lots of variables you have to consider. Sometimes you just got to go with the cheapest thing that you can. It hurts you in the long run, yes, but you got to do what you got to do. So that's unit price. How do we compare 2 things that seem like they're not comparable really, because one is much bigger than the other? So hopefully that idea kind of makes sense. And it's kind of neat because this idea is going to pop up in Unit 4 too. And I'm going to remind you of it. I'm going to say when we do this thing, and maybe in Unit 4, it's going to be like, oh, look at this weird thing Mr. B's having me do. And I'm going to say, no, it's not. Think back to unit price. this is the same idea. So let's make sure we get this because it's important. Okay, so did that work out here? Check it out. Make sure you can kind of reproduce all of this. So the next thing then is this idea of rates, okay? We actually kind of just saw a rate, actually, right? It wasn't a speed necessarily, but it was the same idea here where we have this fraction of units, okay? So, but we're going to use rates a lot, especially next unit and the one after. They're critical in the next couple, so we got to make sure we have this down. So rates are similar to unit prices in that there's a fraction unit here. So it's 2 units smushed together. In this case, speed, like we're driving a car, we would talk about miles per hour. So you should stop here and think about what this actually means, right? And I think it's important to do this because I think it gives you an insight on how you can use units. So I think everyone who's driven a car understands what 45 miles an hour is comparatively. So I think it's not too bad to say, if I said I was going this fast, 60 miles an hour, you understand that 45, if I'm driving 45 and then I go to 60, I increased. So I think things like that aren't too bad to wrap your head around, right? But there's another way that's not just thinking specifically about the 45 miles an hour in its current form that you can understand this. And the way we can do this, it's a little tricky. It's a trick that I love using and is going to pop up later. It's these crazy mathematicians with their math tricks. What does it mean to say I'm going 45 miles an hour? Well, it means that if I stay at that speed, I will travel 45 miles in 1 hour. So 45 miles an hour literally means if I go at this speed and I let 1 hour pass, I will have literally traveled 45 miles. That's what that means. That's it. That's what 45 miles an hour means. It's telling you, okay, drive like that. And if you go for an hour, that's just how far you've gone. So over here, this means that if I drive for 1 hour, how far will I have gone? I will have gone 60 total miles. And so what was the math trick? Well, this 45, there's no 1 here, right? But you can always divide by 1. All I did here was this math trick of saying these are the same number. 45 and 45 divided by 1 are the same. And what it does is it lets me sneak a little 1 down to that hour so I can talk about both of them. So that's what speed is. It's telling you if you know time and if you know how far. So if you know time, you know the speed, you know how far you've gone. It's just connecting all of those things together. Right? So down here I then have a sentence, which this is going to happen a lot. We're going to have sentences we need to deconstruct. Okay, I got this sentence. So what? What does that tell me about this? So in this sentence, which we'll see very similarly all the time, a car is going 45 miles per hour. So how do I know how to write that in terms of my units? Well, there's a key word here, very important, per. Whenever you see the word per, it means when I do my units, I've got to do a division sign. And the way this works is the first unit you told me, so right here, this first unit, well, what's that? That goes on top, miles. And then what's the second unit? Hour. That's got to go on bottom. All right, so that's just one example of many that you can see. All right, so now we are at the meat of this section. All the other stuff was important, but this is our kind of fancy name alert piece here that I was talking about right at the beginning. Dimensional or unit analysis. What in the world is this? So I said above, right at the beginning of units, I said most of you have seen units as just this kind of adjacent side thing, that it's like, yeah, they're there, and yeah, I know they mean something, but whatever. It's not really doing anything for me, right? Okay, 10 meters, 10 feet. Good, I know that I need that, but what? It doesn't do anything. Well, dimensional or unit analysis is all about saying, no, actually, the units can do a ton for you. Because if you understand how units combine, you can solve problems just using that. It's crazy. It's if you understand the units and the way the units have to combine, then you can take a problem that seems kind of difficult to even start, and it can give you a formula, a place to go. Really cool. So what we're going to do here is we're going to look at a specific example of this, although if you take a physics class, specifically, engineering, you would see a lot of this because, it's just such a good way to get yourself going. So here's what we're going to see. We're going to see a lot of, problems that boil down to this equation. There's something I want to measure, thing 1. Something I want to measure, it has its own units. There's some thing 2. It's another thing I want to measure. So if you need an example here, you could think this is something like, distance that the car goes, and this is time. How long does it take? How long do you drive, right? So distance equals time, and then we're missing a piece. It's a rate, right? So if I'm driving in a car and I want to connect the distance I travel with the time it takes me, then I need something here that connects the two. And what's super great about this idea of unit or dimensional analysis is we actually already know what this thing has to look like. This idea, this rate has to look like, because the units of this rate here, the units have to agree with the units here. It's crazy, right? That's idea, but this is what has to happen, is that the units here, we're just going to kind of write it out in terms of ideas, has to look like distance. This rate has to look like distance over time. This is the only way this equation will make any sense. Distance, how far I go, equals time multiplied by this idea of distance over time. It's forced. And so once we get comfortable with this, it makes everything a lot easier, because you're going to read a problem and you might be given a distance, you might be given a time, and you might be asked for, well, how fast are you going? And it might be hard for you to think about, like, how do I combine all these things? And in which direction do I have these two numbers, how do I combine them? You don't even have to think about it. It's the units that tell you, and the units are forced here, right? So let's try to put this into symbols a little bit more, and then we'll kind of keep going through this. So here it is in symbols. Thing 1 equals thing 2 times the rate, right? So when I write it in a formula like this, R stands for the rate. This stands for something I want to measure, thing 2. It could be lots of different stuff. And this is thing 1. So I'm going to put a symbol on it because I don't want to keep writing thing 1 and thing 2. I'm not Dr. Seuss. So we've got this formula. But wait. Doesn't this look really familiar? I feel like I already messed around with a formula that was something like number equals number times another number. This looks so familiar. And that's because it is. This is from the percentages. Remember, back in the previous set of work when we did percentages, so just as our note here, percentages, we had y equals x times p, and p was our percentage, right? So we're just doing the same thing. We're just going to use units to get us into this equation, and everything we learned about percentages, how to solve the problems, that kind of stuff, like all those techniques we use to solve those problems, there we go. It's just the same formula again. All this stuff, the same formula. It's amazing. So let's actually do it, because I'm talking a big game here, but you're not seeing it, right? So let's do it. Example. A very common example is driving a car. I keep using this one. I promise we'll see other ones so you can get a feel for it too. We often have 3 pieces of info, 3 variables in our equation. 3 pieces of info. Distance, speed, time. So here are 3 different examples of questions that we could ask and try to answer. So what I'll say here is, if you're feeling comfortable, stop the video, try to answer these 3 problems. And again, if you feel like you can just think through it without using any formulas, go for it. Yeah, that's fine. It's a good place to be to do that now. That's okay. If you feel like, yeah, I can try using the formulas and fit stuff in, awesome, do that. If you want to use the units, great. However you want to try to attack these, just try. We are going to use the units to help us understand how to solve them. Okay, that's what we're going to do. But pause now and just give these a shot. See if you can figure out how to solve each of these 3. So pause. All right, unpaused. I still don't know why I keep pausing. You're clearly just going to click the pause button. Doesn't matter. So let's go through these and see how we can understand them. All right, we're going to use the units. It's going to be great. We're going to use the units. So number 1, I drive 100 miles at 60 miles an hour. How long does my trip take? Okay, so first things first, we have to identify what we're given. So this first piece here is what we're given, okay? 2 things, because we always need to be given 2 things, right, to find the third. Well, I started by saying we've got the rate. How do I know this is the rate? Well, what did we say? Rate was in this form, miles per hour. It had to be a division, a fraction. So what's really nice, if I'm feeling comfortable, I guess I have it right here, using this equation, where remember, the thing specifically here I want to put is this is the rate. Then if I am given a number and there's fraction units, I can immediately just plop that in. I just go, ooh, I see fraction units, done. Okay, so I got a formula. I can just use the formula. I already put one number into it. Now we're cooking with gas. So, okay, cool. What about this 100 miles, though, right? Where does the 100 miles go? And so there's one thing you could think here, and that's I only have 2 options, which is true. The 100 miles either goes here or it goes here. So, you could just always try both and see what happens, and that's fine, right? But we can also use the units to think about it, because we need the units to work out here. So we're just going to actually try both and see what happens. But hopefully you can see after we finish this example how you don't need to just try them both. You can start thinking about what will happen. It's kind of cool. What I'm going to ask you to be doing sometimes in these math problems is, once we're comfortable with an equation, I'm going to ask you to do stuff like look into the future of the equation, right? How do I know how to use the equation? Well, you got to look into the future a little. And that takes work. That takes, it's intuition that you got to build by trying a lot. But I'll show you what that looks like. For now, we're just going to plug stuff in and see what happens, which is totally cool. But you're going to start to build that, like, I can see into the future with equations thing. And it's a fun thing to be able to do. So, okay, we got this equation. Where's the 100 miles go? Well, let's just plug it in. There's 2 options here. 100 miles I plugged in equals, and then the only other thing left is time. So this has to be X hours. So once you choose where the miles goes, you actually force the other unit, hours, because that's what's here, right, to go in this spot. So it's either this or 100 actually goes here, and then the hours has to go over here. So these are the 2 options. So stop the video. See the green? Again, I think this should be red, but red's scary sometimes, so maybe we'll just stick with green. See the green question mark and pick which of these works. And then once you get a guess, try to think if you can explain why. Explain to yourself why. Explain to someone else. Pretend like you're explaining it to me. So pick one of these and say, why does it work? And here's what I want you to focus on: the units. Why, using just these units, forget about the numbers. The numbers don't matter right now. Why, in terms of just units, does one of these 2 work? So pause, see if you can do this. Okay, unpause. Which one works? The first one works. Why? Well, let's look at this first one here. And This is the big thing we have to think about. Because I keep talking about units combining. And so something that we have to remember is that whenever we're dealing with units and we add or multiply, subtract, divide, our units are also doing that. It's not just the numbers, the units do that. And so when I'm doing this, when I'm telling you to focus on the units, I really just mean what happens when we do hours. So again, I'm going to forget about the numbers here. Times miles per hour. I want you to think about this. What happens when I combine these two things? So think for a second. What happens? Well, I've got hours top, hours bottom. What happens? And I'm multiplying. They cancel. What does that leave me with? Just miles on the right. The right would just be miles. This whole box is just miles. What do I have on the left? Just miles. Hooray! It works. My units on the left are the same as my units on the right. We've done it. So let's see an example where it doesn't work. Let's go to the second one now. The second one, if this was really correct, then when I combine the units, it would be miles times miles per hour. So think about this. Do these miles and hour cancel? No, they're not the same, so they can't cancel. I get miles and miles, and I multiply them. That ends up becoming miles squared, which we're going to see this later, per hour. So I'm not saying that you're wrong at this point necessarily. Usually we're looking for some cancellation. So maybe when you don't see things cancel, you're in your head, you're probably like, uh-oh. But let's double check, because all that we need is that the left side, hours, units, needs to be the same. So again, it's awesome. You see all those numbers in our equation? No way, I don't care about these numbers. I only care about the units. Everything here I'm doing is just units. And so we ask ourselves, are these equal? Are these the same? No way. Hours is not the same as miles squares per hour. This is not the same. So then these not being the same means this does not work. And so, just using units, we know that if I've given you 100 miles we've traveled, and I know I'm going 60 miles an hour, this is the equation I need to use. And so just go use it. 100 miles equals X hours times 60 miles per hour, because the units cancel. So at this point, maybe this equation is kind of, you're looking at this like, oh, look at this thing, it's a monster. Well, guess what? We've got the units down, right? We made sure they work, so forget about them. We don't need these units anymore. We already figured it out. So all we have now is 100 equals X times 60. I know how to solve that. We did this in the last piece with the percentages. Divide. And we end up with X is equal to 1.666666 forever. So that bar means you don't say it forever. It's just, we all know it's going forever. And then you have to remember we need units on this. So don't forget the units. If you forget them, that's okay. Just go back up to the equation. Right? X hours. X is time. Go back up to the original problem. How long does my trip take? How long? So you know at the end you need to write hours. And we can do that. Hours. There you go. So I know that that's a little bit of a process, but if you practice that and you practice that, it'll become a lot faster, and then you can solve so many different problems by just going, how do these units combine? And boom, you've got your equation, done. You've got your setup, done. You just have to do a little bit of algebra. You've knocked it out. All right? So second one, we'll go through these a little faster. Second problem, let's just scroll back up here. I drive for 3 hours, time at 50 miles an hour, rate. So we go down here, okay? And again, I'm given the rate, so I'm going to plug that in, 50 miles an hour. And then we're just in the same boat here. where do we put the time? So just to remind us, it was 3 hours is one thing that we were given. Well, where does that go? Well, guess what? We already did the same thing. We already talked about this. This has to be hours so that the units work. So plug it in. 3 hours has to go here. I need to multiply the two numbers. Look at that. I gave you two numbers. Wait, how do I combine these to get miles? You don't have to keep that all in your head. You write down this formula. You know the rate. Boom, that goes there. Put it in. And then we already know, we just did this, that hours has to go here. That's all units and nothing else. Once you've got the setup, make sure, double check the units. Hours cancels hours. Great. Miles equals miles. Cool. And then get rid of those units. They're just confusing us. Multiply. We went 150 miles. Boom. So let's try the last one. So this is a little different, right? Now we're given miles and hours, but not the rate. So I'm given miles, I'm given hours, and again, it's the same equation. All the pieces go in the same exact spot. You can just do this now. Distance, anytime you ever are in a situation like this, you can immediately write this down. Time times speed. That's all we're doing. We're just creating that formula that we can use for all of time. And so you can remember this formula going forward now because we just pretty much made it up on our own. Or you can just use the units. So miles per hour, that's our speed. Hours, that's time. Miles. So let's just, double check your units. Hours cancels with hours. Awesome. Perfect. So then we know that we're good with units. We know our formula is correct. So do your solving. 150 equals 4 times r. Okay. How do I get r by itself? Divide by 4. So remember, all I'm doing here is just, I don't want this 4, divide. R is 37.5. 37.5 what? Miles per hour. Miles per hour, miles per hour written. Boom. This is the beauty of learning to do all of these things with the one equation, right? This is all about this one equation. I'm losing myself, right? This is all about, if we just use this one equation, we could fit all these different problems, all these different things to this one equation, and then solving the equation is like this, because we just know how to do that. We've done it a bunch of times. Once you get me there, I can solve it. So we're just trying to talk about the different ways to get there. All right, that's it for the unit study guide. Go practice the weekly activity problems, and then start working on the homework. Let me know if you have any questions.